Good morning and namaste, everyone. Hope I'm audible to everyone. Could you please show me a thumbs up if I'm audible? Well done, students. Thank you so much. Thank you, everyone, for joining us here today. I'm Ms. Preeti Bojak on behalf of CP Goenka International School, Ulve. Welcome you all to this exciting session about space and its celestial bodies. As announced by our respected Prime Minister, Mr. Narendra Modi ji, August 23rd is observed as National Space Day in honor of the success of Chandrayaan-3. The spacecraft's Vikram lander made a historic soft landing on the moon's south pole on August 23rd, 2023, making India the first country to land near this region. And today, we are really thrilled to have a very special guest with us. Let us please welcome Dr. Mila Mitra. Dr. Mitra is an expert in space science and has worked with NASA for over 20 years, exploring the mysteries of our space and universe. During her time at NASA, she contributed to various satellite missions and worked on significant projects, including the Cosmic Background Explorer project. She is also the co-founder and academic head of STEM and Space, an organization where she inspires the students to pursue science, technology, engineering, and math. For many of us, the idea of exploring space is nothing less than a dream. And I'm very delighted to say that Dr. Mitra is here today to make this dream feel a little bit more closer to us. So in this session with Dr. Mitra, she will be sharing with us the importance of National Space Day. Why do we celebrate it? The exciting details of the Chandrayaan-3 experiences and what it takes to build a career in space exploration. So students, are we all ready? Are we all geared up? Just imagine you're all there seated in a rocket, and we are all ready to ignite the rocket and take the session off under the guidance of Dr. Mila Mitra. Dr. Mila Mitra, over to you. So we are all ignited and the rocket takes off. 3, 2, 1. Can we all please welcome Dr. Mila Mitra with a big round of applause?
Good morning.
So much, Doctor. Yeah. Over to you.
Good morning. Thank you for welcoming me, ma'am. It's great seeing so many young students sitting here waiting to hear more about space. It's the right spirit of National Space Day. So with that, I'll tell you, I'll go ahead and get started. And ma'am already told you what are the kind of things I'm going to talk about today. So please, students, be with me, and we'll take some questions at the end. So if you have some questions, then go ahead and keep them ready. Okay. Can I share my screen? Can you enable that?
Just a minute, ma'am. We are working on it.
Okay.
Thank you.
Okay. Yeah. So today, as you know, is National Space Day, and it's the first such celebration. This is the first year that this day is being celebrated. So I hope all of you know why this day is being celebrated.
Ma'am, sorry to interrupt you. Maybe you can share your screen now.
Okay, yeah. Yeah, I think everybody can see it now.
Yes, ma'am, we can. Students, please raise your thumb up if you can see. Thank you, children.
Okay, so today we are going to be celebrating together, and all of us are here celebrating National Space Day. So what does National Space Day celebrate? The Chandrayaan-3 landing on the moon, which happened on 23rd August last year. So, this week, tomorrow, last year was a big day of celebration, and all of us witnessed it. And I was actually on media, and I'm often on media for such things, but there's kind of vague interest. But that day, there were people singing in the studio. There were people distributing sweets in the studio. So it was like this movement, this excitement went to each and every person in India. So that was really a great achievement. And today we'll talk about why it was such a great achievement. So as you know, uh, Chandrayaan 3 successfully soft landed in this location on the south pole of the moon. And that location was then renamed by our Prime Minister to Shiv Shakti Point. So there you see a glimpse of the Shiv Shakti Point. And in fact, the rover was able to go even quite a lot further out. Now, here is the moon. The moon is our natural satellite. The moon has been seen by people from ancient times, and there's so many mythologies about it. There's so many stories. Not only that, because the moon is so close to Earth, people could see it move across the sky. It could see it changing over seasons. It could see the people could see the phases change, and that's how even the first calendars came across, the lunar calendar. And people used to look at the moon and wonder, what are those features? You see the picture out there on the moon. People are able to recognize pictures. Some call it the rabbit on the moon. So, so the moon people wanted to know a lot more about. You can see here, there's so many interesting features, right? Some of you know and often see some of them on the moon. So I'll talk a little bit about the moon first. How was the moon formed? If I were there, I would take the answers, but the moon was formed almost the same time as the beginning of our solar system. And there are many theories, and these theories, of course, change as we get more information about the moon from different missions and different satellites. The theories also have to change along with it, because they may not completely satisfy what we're seeing now. And that is how science works. You can keep on changing the premise to see, to match the observation. The main theory that's accepted is called the giant impact theory. Under that theory, when the Earth was just forming, in the very beginning years when Earth was forming, a big object called Theia, and it's not clear if it was an asteroid or another protoplanet, which means planet-like object, it hit the Earth, impacted it, and knocked off part of the Earth. And both the Earth and the moon debris intermingled a little bit. And then the gravity collapsed it to form the moon. And that's why moon has some composition and some features that are similar to Earth, because it actually shared some of the Earth's formation at that time. Okay, so that's the formation of the moon. It formed almost at the same time as the Earth. Now let's talk about some of the features of the moon. We see this kind of shape all the time. Everybody's seen it? Thumbs up. You go out and see it. It's called, many people say it's the rabbit on the moon, because it has ears that you can see if you think of the rabbit as bent. Okay, so the bright areas are called terrae. Those are the brighter areas that you see here. Now the lowlands, all these dark areas are actually volcanic lava that solidified, and they're called mares. The mare is what happened is, long back, there were big impact basins. There were big areas that were empty, like larger craters, and there was volcanic activity on the moon, and that activity filled these craters with lava. So these are the dark areas that we see, and they're called maria. We know that the soil on the moon is very, very fine. It's like talcum powder, and it's called regolith. In fact, that's a problem when missions land. That is one of the problems of soft landing on the moon, because it's so fine that when you land, it just comes up and surrounds you. So even our Chandrayaan 3 had to wait for a few hours for it to settle down before the rover came out. The fourth feature, craters. As you all know, the moon has very little atmosphere. So there are, on Earth, when asteroids or meteors come, many of them are, burnt up by the atmosphere. But in the case of the moon, they actually make it all the way to the moon and they create a lot of impact craters. And that's what you see on the moon. Now, as you might know, there's a near side and a far side of the moon. For many, many years, we could only see one side, the side with the rabbit. And we could only see the far side a lot later, when in the 1950s, when a mission called Luna, flew around the moon. So only when satellites started orbiting or flying around the moon, then we could start getting pictures of the far side. And if you see this picture, you'll see the near side and the far side are very different. The near side has a lot more of the Maria, the black volcanic lava, and the far side has many more craters. So the theory is, I mean, can you imagine Earth looking different on two sides? How did that happen? How did that happen to the moon? So the theory is that, there's also a large crater at the South Pole called the South Pole Aitken Basin. It's twice as deep as Mount Everest is tall. So you can see how deep it is. It's moon's largest impact feature. So one of the theories is that this was formed and there was a large volcanic activity at that time. And and the volcanic rock went to one direction, and volcanic lava and the internal heat went to one direction. And that's why there are more Maria on one side, which is the near side. Now, I just said that we can only see one side of the moon. And I'm sure most of you know why is that so, right? But I'm going to repeat it. The moon takes approximately 27 days to complete one rotation. As you know, the moon rotates on its orbit, and it also revolves around Earth, just the same way that Earth rotates on an orbit and revolves around the sun. But the revolution of the moon around Earth also takes 27 days. So the revolution and rotation is the same. Therefore, this is what is called synchronous rotation. So you can see from the picture, because it takes the same time, the same side of the moon always faces Earth, and therefore we need to go away from the moon. And that's why till satellites and flyby missions started going away from the Earth and outside the orbit of the moon, only then could we see what the far side looks like. This is called synchronous rotation. And in fact, it's called tidal locking. How did this happen that moon's rotation and revolution is the same? Is it just like a big chance of luck? No. The tides, they have, Earth and moon has gravitational pull on each other. So this happened over time, that the gravitational pull on each other stabilized, and that is called tidal locking. And as you know, the moon also exerts influence on our tides. So this is how it works. We see one side of the moon. So like I said, from ancient times, people were interested in what does the moon look like? What is it? And are there any other objects like the moon? So all this was slowly led to, why should we go to the moon? But in more recent times, when moon explorations started, by then people knew more about the moon already. And there were some very strong points of why we were interested in going to the moon. Okay, so moon is like a geological time capsule. What does that mean? Because there's no atmosphere or very, very little atmosphere, and now the moon has less volcanic activity. So whatever happens on the moon stays on the moon. That's why one of the first astronauts made a footprint on the moon. And the question still is the footprint is probably still there. The more important thing is moon is so close to Earth that it makes it really a great space lab to test out space technology because we can go to the moon and come back. As we go further out to Mars or anywhere else, it will be harder and harder to come back. So moon, makes it easy for us to test out space technology that can be used for further space exploration. Similarly, being on the moon will help us understand about space radiation and how other space conditions can affect astronauts. Moon also has very low gravity. What is the gravity on the moon? 1/6. So that's why they always show pictures of astronauts jumping on the moon. So because of the low gravity, it is again a good place to test out launching and other rocket technology. And this brings in a higher question. Why did humans want to go to space? Now, can I see a show of hands? Who wants to go to space if you got the chance to go? Okay, so definitely myself too. So, but how did it start at that time? It's because we wanted to understand, where is Earth? I mean, now we know it's all the space exploration and space telescopes have taught us that Earth is in the solar system is in the Milky Way galaxy, and the Milky Way galaxy is part of many other galaxies. So now we know all that. But the main thing is we wanted to know, and we still want to know, where are we in the universe? Is there other life in the universe? And at that time, in the 1950s, there was also what is called the Cold War. So there was a lot of politics playing out between USA and Russia or USSR, and they both wanted to demonstrate technological superiority and how best to demonstrate it, but to go to the moon or to show that we have space or to show that they had space capability. Additionally, there was the fear that if anybody gets space capability, will they able to throw missiles from space? So you also wanted to have the equal capability. That's how lunar exploration started in the 1950s. The first missions to go to the moon were in fact the Luna missions by USSR. Luna 1 was just like a little metal ball, like a size not much larger than a football, and it had a lot of antennas so it could communicate back. Luna 2 was the first to impact the moon. Luna 9 was the first to actually achieve a landing. And one sec. And Luna 10 was the first to orbit the moon. So from that, we already started getting some information about or images of the moon. What does it look like? And that's what started the Apollo, or not Apollo first, but first, that's what started NASA missions too, because NASA also wanted to get to the moon. So before Apollo, there were some other missions called Mercury. And, all of those were testing and building more capable space vehicles. Finally, the Apollo missions in 1961 onwards were successful. So Apollo missions had 9 missions and 24 astronauts that orbited or landed the moon. And so far, it still is the only mission that has, these Apollo are the only missions that have ever reached the moon. After that, what I mean is ever reached, these are the only crewed missions where humans went. And after that, humans have never gone to the moon again. So Apollo 11, so let's come back to Apollo programs. In 1961, President John F. Kennedy committed the US to landing a person on the moon, and he said it's got to happen within that decade. And 6 of the missions did reach the moon. 12 people walked on the moon, and the last mission was in 1975, or Apollo 17 was the last mission. And 52 years later now, the 6 Apollo missions remain the only crewed vehicles that landed on any surface beyond Earth. So that's why Apollo missions have gone down in the history of moon exploration. And I'll just give you a few brief glances of Apollo 11 mission, because that was the first lunar landing by humans. And the first astronauts, as you know, was Neil Armstrong, Buzz Aldrin. They reached the moon, and Michael Collins was in the command module that orbited the moon. So the astronauts could come back up from the moon in a lunar module and join him, and then they came back to Earth. So you may not know Michael Collins' name so well, but yes, he was part of that same mission. So first humans on the moon, and they had a very strong, powerful rocket called the Saturn V rocket. And the landing was on July 20th, 1969, and they spent 21 hours on the moon. So this is what the mission control looked like then. And all of you do see mission control pictures that we have now at ISRO and at NASA. And they were actually trying to watch the launch from this window. And the Apollo astronauts took a picture of the Earth. And that's when they realized that Earth also looks like it has phases, just like the phases of the moon, because the phase, of course, is only a play of light. How when the moon, we see phases of the moon because of the way the light falls off it and how much it's where it is in relation to the sun and the Earth. Now, this is the famous landing where Buzz Aldrin made the phrase, "That's one small step for man, one giant leap for mankind." This is the plaque left on the moon. Plaque is like a metal, like a trophy kind of thing. It says, "Here men from the planet Earth first set foot upon the moon. We came in peace for all mankind." Because we always want to leave a message for peace in case some other civilization or aliens find signs that we have been on the moon. Now, these are the first scientific instruments that Buzz Aldrin deployed. There's a seismometer. Seismometer, everybody knows probably, is measuring earthquake or tremor activity of the surface. Or the US flag and the lunar laser retroreflector, LRRR. I just want to mention this because Chandrayaan 3 also had a similar experiment. Now, what this does, it lets you shine a laser beam and actually reflect back from it. And this helps you determine the distance from the Earth to the moon. So like I showed you, a large part of what all these astronauts did in the Apollo mission were collect rock samples. And these samples have told us a lot about the moon composition. And as our technology gets better, we are also better able to date the age of the moon and what the moon composition is. So why did this very successful US lunar program end? Because they were very expensive. The launch vehicles were also very expensive. Our Chandrayaan missions are much cheaper. You hear that. And why is it cheaper? Because we are not sending humans. So we say it's okay if it takes more time to reach the moon, but we'd rather, so it's like a balance between budget and how fast do you want something to get there. But with humans, of course, you need everything to happen fast. Now, the Apollo missions had already achieved many successful goals. They got back samples. So, sending humans to the moon, continuing to send at that time, was not going to help much. But now we know a lot more about the moon, and we humans are still aiming to explore the moon. Why? Some reasons are because we know that how far away the moon is. We know there might be water ice that Chandrayaan 1 even has identified. So we feel that it's a great place to build the first lunar settlement because there's water ice. That means that there's a possibility of creating water, of the water can also be used to create oxygen and fuel. Because the moon is not so far away, it's a great place to explore space technology and test new technologies to prepare us for space exploration further beyond. So, with these considerations, lunar explorations of uncrewed vehicles are still going on. And that's where Chandrayaan came in and made its mark. Okay, so Chandrayaan means moon and vehicle, right? Chandrayaan. So, all of you know that so far we've had 3 Chandrayaan missions: Chandrayaan 1, 2, and 3. Let's find out a bit about all of them. Chandrayaan 1 was India's first mission to the moon. In 2008, most of you were, maybe not even born. So this happened in 2008 with the PSLV rocket, and the only components were an orbiter that orbited around the moon and an impactor. Impactor is a space vehicle that's designed to impact. It means it can be a hard impact. We're just crashing it on the surface of the moon. But while crashing it, we get some great images as it's getting closer. And its experiments can record the composition of the moon as it's crashing there. Okay, so again, what are orbiter? What's an orbiter? It's a spacecraft designed to orbit without landing. As an orbiter orbits, it can keep on taking images of the object. What's an impactor? This was called the Moon Impactor Probe, and it crash landed, in fact, on the South Pole. And while it crash landed, you can see pictures of the impactor separating, and then it actually crash landed. And that is when India, in fact, became the 4th nation to place its flag on the moon. So just the lunar technology to achieve this, going to the moon and able to crash land, was itself a big achievement. And additionally, the moon impactor actually discovered water ice on the moon. So this was a big discovery. So Chandrayaan 1 was already able to show that we have the technology to reach the moon, and the impactor showed that there may be water ice on the South Pole. Why the South Pole? Because the South Pole and North Pole of the moon are very different. Not the North Pole, sorry. The equatorial areas are very different. They've had a lot of missions land on it, but the polar regions are permanently shadowed. The sunlight doesn't reach there, so they're very cold, and that is why water may be there in the form of ice. But it's also very difficult to land. It has more craters, and it's also unmapped because most of the missions have not landed there. That's why landing on the South Pole was a big challenge, because nobody knew exactly what the area would look like. And but the achievement was, we need to land on the South Pole to try to discover water ice. Okay, so this is now Chandrayaan 2. Chandrayaan 2 was aiming to aiming for the South Pole. And as I've already told you, South Pole is difficult to land on. The Chandrayaan-2 had several parts. The Vikram lander. The lander, Vikram lander, I'll come back to it, but it's named after Vikram Sarabhai. Vikram Sarabhai was one of the prominent scientists who started ISRO, and he's called the father of the space program. There was also a rover, small rover that was inside the lander, and it's called the Pragyan rover. Pragyan means knowledge in Sanskrit. Okay, so what was Chandrayaan-2 aiming for? To demonstrate the ability to soft land. What does soft land mean? It means you don't crash on it, but you orient yourself properly so that you just land. Imagine throwing, a ball and letting it land on sand. It's going to impact, right? It's going to turn around. Imagine throwing a plane, like a model plane. It has to actually start from a horizontal position and orient itself vertically and land perfectly. It also has to decrease its speed so that it lands without a crash. So the demonstration itself of landing softly was the main goal. There were also experiments to look for water ice and to study the lunar surface and the atmosphere just around there. So this is India's second mission to the moon, launched on July 22, 2019. It had a more powerful rocket. And as I told you, these are some prominent features of the moon, and that's the Tycho crater in the South Pole. Most missions so far had landed more in the equatorial area, which had been well observed. So, you need kind of a mapping to know where you can land. The South Pole near the Tycho crater is where our Chandrayaan-2 was aiming for. And why? One of the reasons is because Chandrayaan-1 had discovered water ice, and we wanted to find out if it was actually there. Okay, so this is the Chandrayaan-2 landing site near the South Pole. Chandrayaan-2 had three components, just like I told you. The orbiter, which was just going to orbit, but the orbiter is what was carrying the lander and the rover. So the orbiter released the lander and the rover that was inside the lander. Okay, so again, the orbiter was just going to stay around, and it itself had a lot of payloads. One payload was, what is a payload? It's an experiment. One payload was a high resolution camera that really sent back very high resolution images of the moon. The Vikram lander was designed to soft land and on the South Pole, and the rover Pragyan was designed to come out and move around the moon so that you can do on-site analysis. It's called in situ, means you can go around, tap on the moon surface, and get some samples and results. However, like you know, the Vikram lander, when it descended, it moved away from its landing point, and in fact, we lost communication. And was it a failure? Scientists don't feel it was a failure because it demonstrated technology up to that point, and that itself gave us enough information that we were able to remedy these for the Chandrayaan-3 design. So this was just another, we learned a lot from Chandrayaan-2. And Chandrayaan-3, therefore, was the next mission being that was designed, and it was built on the learnings from Chandrayaan-2. So there was a much more improved design of the lander. The rover was still there inside. And again, the objective were the same, to demonstrate safe and soft landing and build on the experiences from Chandrayaan-2. And Chandrayaan-3 did achieve the first successful soft landing on the moon, which made India the first country to soft land on the South Pole of the moon. This was India's third mission to the moon, launched in 2023, July 14th. And even our launch vehicles were getting more, powerful. LVM-3, this is called. We had a lander rover and the propulsion. Now there was no longer, let me just go back. There was no longer an orbiter because that orbiter is still alive from Chandrayaan-2 and it is going around the moon and it is sending data. So it was no longer necessary to have an orbiter, but now there was a propulsion module because you still need something like a rocket to carry you all the way from the Earth to the moon. So this was the propulsion module. And we still had the lander with much better design. Again, just think in your head, if you're sending a model rocket and it flies out horizontally and with a lot of speed, but it has to land vertically and decrease the speed to zero as it lands. So based on all that, you have to have very strong thruster engines which decrease the speed as you're going down. This one had stronger legs as you're going down, so it can keep the balance. It had bigger solar panel and it carried more fuel. Also, it had very good cameras that almost provided artificial intelligence in terms of as the cameras saw the terrain, even when you were very close, as the lander was going down, then it was sending back the information to the lander so it could shift its position a little bit. So the camera and the lander were working together to detect any obstacles and avoid it by just a small margin. It had the power to do that. The propulsion module carried the lander and set, at a 100-kilometer orbit, it released the lander and the rover. The propulsion module has one experiment or payload of its own. It's called SHAPE, Spectropolarimetry of Habitable Planet Earth. It observes the Earth from the lunar orbit. It's pretty interesting because so far, Earth is the only planet we still know that has life. So when this experiment observes Earth with it takes a spectra. What is spectra? It measures the atmosphere and it can analyze what composition the atmosphere is. Now this becomes a baseline of a habitable planet. And if we observe other planets from space, now we are observing exoplanets in other solar systems. So this becomes a baseline of a habitable planet and what its atmosphere can show. So what was the objectives of the mission? Demonstration of safe and soft landing. So I haven't... also, that was the celebration moment that I shared. Many of us saw it on media. The other thing was demonstrating the rover coming out of the lander and moving. That's what the word roving means. The rover actually had to move around and take measurements. And here's a picture of the rover. Here's a video of the rover as it's made its way out of the lander. And like I said, it happened a few hours later, and the rover successfully came out of the lander and it's moving. And it's very hard to move on the moon because of the craters and the regolith, which is so fine. So the rover actually has a special mechanism of the wheels. It's called the rocker bogie mechanism, which lets its wheels operate separately from each other. So the two front wheels operate separately from the back wheels, which enables it to climb over small craters or small features. So the rover also had to demonstrate the movement, and both the lander and the rover aimed to do some experiments. And I'm just going to talk briefly about some of the very successful scientific results. First result was, okay, uh, the rover was actually able to share the photographs that it was taking with its navigation camera and send it back to ISRO. And this is all with a very small time margin. Of course, it takes time for anything from the moon to reach the Earth, signals from the moon to reach the Earth, but it was able to signal that there's a big crater, and ISRO scientists were able to command it to turn around, and it was successfully able to turn around and avoid the large crater. So it was taking commands, and its camera images were being sent. It was able to demonstrate the successful navigation and command uh, intake and signal intake. Okay, so here are just a few other experiments. The Chandrayaan had an experiment, the lander had an experiment called the CHAST. It's a surface thermophysical experiment. You just saw how it deployed. It's just a stick. It deployed and touched the surface, and then it drilled down like a real drill. And so, what did it find? It found something very interesting. At just 8 centimeter depth from the surface to the 8 centimeter down, there was a temperature difference of 60 degrees. If you do this on Earth, you'll find only like a few degrees difference between the surface and 8 centimeter down. But here they found 60 degrees, which indicates probably that the surface the soil is a good insulator of temperature, and that again makes it more hopeful for us that there could be water ice if the soil is able to preserve the temperatures so much colder at just a little bit lower depth. So this is the CHAST experiment, Chandra Surface Thermophysical Experiment, and that showed that there was a big temperature difference between the surface and at a small depth. Here's another interesting experiment called the ILSA, Instrument for Lunar Seismic Activity. Now, this ILSA was going to measure the earthquake kind of activity, or just waves, gravitational waves. What I mean is, are there any kind of activity on the surface? Now, this is the picture that it was correctly recording the vibrations due to the rover movement. This payload was on the rover. It also may have found a moonquake, so a moon activity. It found, it recorded something like this, which was a much bigger amplitude, much bigger movement. So it may have recorded the first moonquake since the 1970s. Now, there's another rover payload called the LIBS, Laser-Induced Breakdown Spectroscope. What did it do? It just shot a laser beam on the surface of the moon, which vaporized some of the surface soil, and it became like a vapor. And that instrument was able to measure the vapor with a spectroscope, which again shows you lines of the composition. Each line tells you what elements may be there in that cloud that it was formed, and it confirmed the presence of sulfur. And sulfur again indicates volcanic activity. So these were some very interesting finds. And so not only did ISRO's Chandrayaan-3 show a successful landing, but it also showed, a successful soft landing on the South Pole, which made us the first country to do so. It also showed that the rover was able to come out and take measurements. It was able to communicate back to ISRO with ISRO. And also both the lander and rover payloads have contributed strong and wonderful scientific results. So congratulations, ISRO, and Chandrayaan-3 has really put India on the roadmap, so that all countries now acknowledge India and ISRO as experts in space technology. And that, of course, opens the door to many collaborations. It also opens the door that ISRO has already started taking payloads from other countries, and our launch vehicles are now releasing rockets and payloads from other countries. So we have become a space technology leader. Now, what is coming next? There are more moon explorations in the pipeline for other countries and for India, maybe. So NASA's Artemis is the next lunar human landing that is in the plans. With the Artemis campaign, NASA will also land the first woman and first person of color on the moon, because earlier there were only white men that had been able to land. So they're also aiming for diversity. So Artemis will be the next mission that lands humans back on the moon. Why are we going back to the moon? Like I said, this is inspiring a new generation, and you are all called the Artemis generation, because this opens up so many doors for space exploration. Artemis plans to return humans to the moon, establish a moon base, and also demonstrate a lot of space technologies and create a lunar gateway. The same way that we have the ISS, that is like an Earth lab, they are going to create a lab around the moon that will be an orbiting outpost that supports long-term exploration. And from there, astronauts or missions can go further out. So it's many missions out there under Artemis. The first test mission, Artemis 1, has already occurred, and Artemis 2, with the first humans, may go as at the end of 2025. So that may be coming up, students. So that would be a wonderful thing, return of humans to the moon. Now, with this, all of you can tell that space exploration is really poised for unprecedented growth and innovation and technology. And you all know that we've gained so many things from satellites and space exploration. Internet we've gained, mapping, communications, satellites give us so much information and so many things it has given to the modern world. And more as we get into space exploration, it will create better technology and innovations. So that now many governments have their space agencies that are collaborating for further out space travel and space exploration and space technology. So you are all students, 20 years later, already where we are now. From 20 years back, we've come a long way in terms of our technology on Earth, much of which is even due to what has happened in space. So the same way, there are many space careers that are going to come up in your future. So I'm going to share some things that you can do and how you can orient yourself. And I want to share that STEM in Space, of which I'm co-founder, has released a comic called Discovering Space Careers. And I'll tell you at the end how you can also receive this comic for free. Okay, so now there's a lot of confusion between, do you want to be an astronaut or an astronomer? People think that they can be either one of them, and maybe they can, but let me just tell you briefly what's the difference. Astronomers don't go to space. They stay here on Earth. They observe the celestial bodies with telescopes, with space telescopes and ground telescopes, and they create theories about what is there in the universe. Astronauts are professional space travelers. They actually go to space, and some of them are indeed scientists. They carry out these missions. Yes, so this is an astronomer, again from that space comic, and this is an astronaut, and astronauts go to space, and many astronauts just go to the International Space Station, where there's a special gravity, they have the gravity works in such a way that it's called microgravity. So there's almost no gravity. So that's a very wonderful space lab that enables us to test how the effect of no gravity would be on the human body. And it also lets us conduct experiments that cannot be done on Earth. So there are many roles you can have as an astronaut. But astronauts have to undergo extensive training and they have to be very physically fit. And as you might know, our Gaganyaan now has 4 astronauts, and out of them, 2 have been selected and they're undergoing training right now. Here's something else. These are some common roles that you might know that work on space exploration. Aerospace engineer, that is a good field to go into if you're interested in working with space vehicles, in the design, development, and applying the engineering to this kind of technology. But do you have to be a rocket scientist to go into space careers? Can you have other backgrounds? Yes. Nowadays, space is very interdisciplinary, and you can go into chemistry, biology, computing, you can go into earth science and geography, design and technology, you can go into climate, and there are still roles for you. So I'm going to give you some new kind of space careers that have been coming up, and you can go into any of these fields and still be working with space. Space doctors, food engineers, astrobiologists. So space doctors are already there, and we will be needing more and more of them as space missions with humans go to space. So they conduct the pre-flight medical exams. They have to continuously monitor astronauts' health because in that low gravity, astronauts are affected by, their bones are affected, the blood is affected, and so there is research needed to understand the effects of space travel. What is a space food engineer? They have unique challenges, unlike food engineers here on Earth, because any food that goes has to stay for a long time. It has to stay in that microgravity conditions. So there are innovative ways that they have to think of to preserve the food and even maybe to grow food. And also, astronaut nutrition is a very important point. Now, you can even be a space lawyer. You can go into law and still be a part of space because nowadays, with so many missions going to space, so many, we have landed on Chandrayaan. Does that make us does that land belong to us now on the moon? So it doesn't. So that's how lawyers have to navigate and create international space treaties that every country has to use. So these are the new kind of things that are coming up now: space tourism, space mining, and our comic actually has addresses many of these current careers and even future careers. Okay, so if you want to get hold of this comic, it also tells you what you need to study and what kind of tools you use. So I'll show you this at the end: stemandspace.com/quiz. You can do a little quiz and very easy quiz and get this comic. So if you want to go into such careers, do get into these fields of, STEM fields: math, physics, biology, chemistry, even geography, and of course, computing is important. And you can do any of these extracurriculars like astronomy, robotics, tinkering, and aeronautics. You can do STEM workshops, participate in science fairs, take part in Olympiads. Okay, so you do have to go to higher studies, mostly graduate school in engineering or in hard sciences. Be investigative in the kind of things you do. You don't have to be a certain kind of person to do STEM. Like I showed you, you can be a doctor, you can be a lawyer, and still you can come into being a space engineer. Okay, so there are many emerging fields coming up: robotics, artificial intelligence, satellite habitats, mega constellations. So there are many things you can go towards in the next 10, 20 years. Okay, so there are a lot of advances in technology. And with that, I want to show you one more thing, that we have a Cosmic Kids Club. You can join that for free. There are a lot of videos and comics Okay, you can participate in challenges. And with that, I'm going to end my talk today, and I hope you all enjoyed learning about space. I hope you're all inspired to go into space careers. And today, again, let's all take the chance to congratulate ISRO and congratulate ISRO and wish ISRO and NASA and ESA good luck as we move further forward into lunar and space exploration. So with that, thank you. And if you have any questions, I'm not sure if the teachers can bring the questions to me, but please join us at STEM and Space if you want to do other workshops, or if you want to join the Cosmic Kids Club or do the quiz with us. So thank you, everyone. And with that, I'll stop sharing.
Thank you so much, Dr. Mitra. Every minute and every minute information you provided was extremely inspiring and insightful today. Students, do we all agree to it? Did we all enjoy learning? Can we all give a big round of applause? Thank you so much, Dr. Mitra. And as we conclude today's sessions, I would certainly like to express my sincere gratitude on behalf of the CP Goenka International School Ulve team to our principal, ma'am, Dr. Smita Gandhi, our vice principal, ma'am, Manpreet Kaur, who actually facilitated this remarkable opportunity for us. So I really extend my heartfelt thanks to all of them for facilitating this session. And a special thanks to you, Dr. Mitra, for joining us today and providing such an insightful session and giving us information about the moon's role as a geological time capsule, and for sharing fascinating details about the space race and providing a comprehensive history of moon missions, including the Apollo missions, the India's Chandrayaan projects, the mesmerizing videos of Chandrayaan, including the landing they were really very captivating. I would also like to extend my special thanks to Mr. Gautam Agwari, the founder of STEM and Space Organization, for connecting with our school today. And your insights and supports have certainly inspired our children today at school. I would certainly like to call them as Artemis and not students anymore. They are now Artemis generation, because
That's
I know many of them would certainly want to reach out to the moon. Thank you so much, Dr. Mitra. Thank you, Mr. Agwari.
Thank you for inviting me. And it was a great chance for me to interact with so many students. Thank you, Dr. Gandhi, Preeti ma'am, and Manpreet ma'am for inviting me. Thank you.
We certainly I would like to call upon Principal ma'am.
Yes, Preeti, I'm here.
Yes, ma'am. Over to you, ma'am.
Thank you. Thank you for hosting it so well, Preeti, and deepest gratitude to Ms. Mitra and your entire team, ma'am. Thank you so much. I mean, your session was truly inspiring, and I think it was a perfect way to celebrate the National Space Day today. I mean, nothing better could have happened, than this. And a woman scientist, the children listening to her, because normally children have this image in their mind that whenever they imagine scientist, they imagine a man wearing, that scientist coat, and you being there on the screen and sharing such inspiring and insightful insight. I mean, our day, I would say this would be the most enthralling day of this academic year, I would say. I wouldn't mind saying that. Thank you so much. Your presence, your insights are really going to create that wave in my children to really deep dive into this space science, deep dive and try to make some career out of it. I'm sure you have piqued that curiosity in my learners. So thank you so much, ma'am. I really look forward to more such collaborative opportunities. And from the entire CP Goenka group of institutions, I once again thank you from the bottom of my heart. Thank you so much.
Thank you. Thank you again, and happy National Space Day, everyone. Let's keep celebrating every year on this day, and please share with all your friends and family that, we've come so far in space exploration, and we plan to keep doing this and moving ahead.
Yes, thank you, ma'am.
Before we leave,
I just had I had a question before we leave, ma'am. That there's always this thing going on that we manifest and the universe catches it and it assists us in creating or maybe reaching to that goal of manifestation. Like, how true is it?
I'm not sure how to answer that, but I've always felt that to be, of course, in space, we see that. I mean, people who work with space, because it's so far out that you don't know if something can really happen. You can't even visualize it happening, but you work so hard for it that scientists, time and time again in space exploration, have manifested, amazing missions and rockets and launches that seemed like it was unbelievable when you started out. So there's a lot of perseverance that can make you manifest something, and space industry has, in fact, of course, proven it time and time again.
Thank you so much, ma'am. So can
Thank
we
you.
all manifest that we will all certainly be one day to the moon
Yes,
as
for
a
sure.
space tourist?
Ma'am, I would just like to, thank you for highlighting that one line, one small step by a man and a big leap by a mankind. That
Right.
line is so, so inspiring.
Yeah. And I hope we're all inspired. And yeah, I think space is very inspiring. And, that is
Yes.
why people like us also, use space as the way to interest children in STEM, because everybody's so excited by what happens in space.
Thank you so much, ma'am.
Thank you. Thank you. Uh, Everybody, happy National Space Day.
Wishing you to a very happy National Space Day. Thank you so much, ma'am, for joining in. We'll be ending the
Okay.
session.
Okay. Thank you.
Thank you, students. Thank you, teachers. Thank you, everyone.